Hello, you are listening Radio MITWS India.
Greetings, my name is Anthony FUCILLA. I'm a philosopher and a science and science fiction author. I would like to thank Radio India and Karen for this brief presentation concerning Mars, the future of Mars, and so forth. Now, Mars was formed 4.5 billion years ago inside a solar nebula when dust particles clumped together to form the planet. At just under half the size of Earth, it's quite a small planet, which is accredited to Jupiter forming first. Now, Jupiter's immense gravitational field, the immense gravitational force of Jupiter, the giant gas planet, consumed vast amounts of available material that would have otherwise contributed to Mars's growth. So in other words, its immense gravitational field robbed Mars of much of its potential material and mass as it formed and reached hydrostatic equilibrium. In fact, Jupiter's strong gravitational field prevented another planet forming in between the two, and instead left the asteroid belt. Now, in terms of Mars's diameter, it's 6,779 kilometers. Average temperature on Mars is minus 63. Now, the surface of the planet is scarred by huge geological features, craters, canyons, and volcanoes. In fact, its lack of folded mountains, like the ones on planet Earth, indicate that it has no currently active plate tectonics. This means that carbon dioxide cannot be recycled into the atmosphere to create a greenhouse effect. Now, this is the reason why Mars is unable to retain much heat. In terms of its moons, it has two moons, Phobos and Deimos. In terms of communication delay between Earth and Mars, it's minimum 4 minutes, maximum 24 minutes. Now, it takes Mars 687 Earth days to orbit the Sun. As its orbital path is not in sync with Earth's, it goes through a 26-month cycle of being closest and furthest from us. In other words, the distance between Mars and Earth is variable due to their elliptical orbits around the Sun. The distance between Mars and Earth at their closest points equates to a distance of 35 million miles, which is 56 million kilometers. This is known as opposition. At their furthest points, the distance equates to 249 million miles, which is 401 million kilometers. This change in distance means spacecraft destined for Mars are sent in a launch window every 26 months, when Mars is closest to Earth. Now, regarding Mars's atmospheric composition, well, it's approximately 95% carbon dioxide, 3% nitrogen, and 1.6% argon, with minimal traces of water and oxygen. Now, Mars is not geologically active. However, it does experience extreme weather conditions. Tornadoes, 10 times larger than anything similar on Earth, can be several miles high and hundreds of meters wide. This in turn creates miniature lightning bolts as the dust and the sand within become electrically charged. Now, regarding its gravity, Mars's gravity is about 38% that of Earth, with just 10% of the mass. Now, regarding Mars's red color on the surface, this is the result of rusting, due to iron present in the rocks and soil reacting with oxygen to produce an iron oxide. Now, in terms of the trip to Mars, it will take astronauts around 7 months to reach Mars, and it's only possible to fly every 2 years. That's because of something called orbital mechanics. They would have to leave at the right time when the Earth is at what we call the perihelion, or the closest point to the Sun of the orbital path to Mars. Spacecrafts to the Red Planet then use a special trajectory called the Homan transfer orbit. This works because of a law in orbital mechanics. The law states that if you can increase the spacecraft's energy at perihelion, you can increase the aphelion of its orbit, which is how far it gets from the Sun. However, you also need to make sure you arrive in position in Mars's orbit around the Sun at the same time that Mars itself does. The alignment occurs only once every 2 years. Furthermore, it takes Mars 687 Earth days to orbit the Sun. Once we colonize Mars, we will need a 24-month calendar. Once we colonize Mars, we will need a 24-month calendar. One Martian day is 24 hours and 40 minutes. In other words, the human biorhythm will be altered for all time. Furthermore, one time there were huge oceans on Mars, and it is now believed that the water must be beneath its surface. Now, in terms of farming on the Martian planet, the soil on Mars is very fertile. Mars has the essential ingredients plants need to grow. These are nitrates and, of course, ammonium. Its atmosphere and soil contain many of the main elements crucial to life. Now, in terms of dust storms, Mars has dust storms that can cover the entire planet for a whole month. This does not happen often, but smaller dust storms are quite common. Dust storms are most common during the perihelion, when Mars is at its closest point to the Sun. Now, in terms of terraforming the planet, it's all to do with thickening the atmosphere, warming the planet and initiating a greenhouse effect, and allowing water to exist on the surface in liquid form. Now, greater sunlight absorption is key in terraforming the planet, heating the planet and releasing carbon dioxide into the atmosphere, creating a greenhouse effect. Thus, over time, an atmosphere will be produced. Now, the ways that this can be achieved? Well, one of the ways is this: to redirect comets and asteroids to crash into its surface. This would release gases from both the impactor and the surface, as well as creating enormous amounts of heat. The other way is to pump out huge amounts of greenhouse gases into its thin atmosphere, like ammonium and methane. This will thicken the atmosphere over time. Thus, importation of hydrocarbons is key. Next, introduction of algae. The introduction of algae can break down carbon dioxide to make oxygen, and it could help lower Mars's albedo, which in turn will help Mars trap more of the sun's heat rather than reflecting it back out into space. Basically, algae breaks down carbon dioxide to make oxygen, and its dark colour will help to lower Mars's albedo. Again, this in turn will help Mars trap more of the sun's heat rather than reflecting it back out into space. With regard to turning the red planet blue, Mars has vast amounts of water frozen as ice, both in its polar caps as well as underground, all the way down to the mid-latitudes. Increasing the temperature and pressure on Mars will allow this ice to melt to form lakes and, of course, rivers. Now, the use of orbital mirrors is also key in terms of heating the planet and maximizing sunlight absorption, which in turn reduces the planet's albedo. By using orbital mirrors, you will maximize sunlight absorption, reducing the amount of sunlight that is reflected back out into space. So by reducing the planet's albedo, you maximize sunlight absorption, you reduce the amount of sunlight that is reflected back out into space, so the ground would then absorb more sunlight. As a result, it would warm the atmosphere. As a result, it would heat the planet, melting the ice caps and slowly releasing CO2 into the atmosphere, thus creating a greenhouse effect. So in short, orbital mirrors is all to do with maximizing sunlight absorption. As you maximize sunlight absorption, you heat the planet, you reduce the planet's albedo, you reduce the amount of sunlight that is reflected back out into space, so you maximize sunlight absorption, you heat the planet, and slowly, through a greenhouse effect, you terraform the planet. Finally, sending special rovers to the planet, which can produce oxygen, is another way to help terraform Mars. Using the gas that's the most abundant on the red planet, carbon dioxide, the instrument will make oxygen and carbon monoxide before releasing it into the atmosphere. Now, in terms of some of the problems we could face on Mars, well, firstly, Mars lacks a magnetosphere. As a result of multiple asteroid strikes, its magnetosphere was wiped out. As a result of multiple asteroid strikes, its magnetosphere was wiped out. Hence, the planet is bombarded with lethal cosmic radiation. Ultraviolet light, gamma rays from pulsars, neutron stars and supernova, highly energetic particles, lethal cosmic radiation. Now, this is a serious health risk for humans in terms of potentially getting cancer and so forth. So it's a serious health risk for humans to be subjected to that enormous amount of cosmic radiation. As I said, ultraviolet light and gamma rays. Lethal cosmic radiation, highly energetic particles. So Mars has no protection against this deadly radiation from space because it has no magnetic field. Thus, the colonists may have to live in large, shielded habitats to protect themselves from this harmful radiation. Of course, these domes, these habitats would have to be built from special alloys that are able to repel deadly cosmic radiation. Also, the lack of a magnetosphere could also pose problems in retaining an atmosphere. In time, solar winds could tear away at the atmosphere. In fact, solar winds are constantly eating away at Mars's upper atmosphere and ionosphere. So once we produce a thick atmosphere on Mars suitable for human existence, these solar winds could eat away at the thick atmosphere produced. Now, a way that we could bypass this problem basically a solution? Well, NASA are planning to launch a giant magnetic shield into space to protect Mars from solar winds. A powerful enough magnetic shield launched into space could serve as a replacement for Mars's own lost magnetosphere. In short, the giant magnetic shield will eliminate many of the solar wind erosion processes that occur within the planet's ionosphere and upper atmosphere. Furthermore, if the solar wind were counteracted by the magnetic shield, Mars's atmospheric losses would stop, and the atmosphere would regain as much as half the atmospheric pressure of Earth in only a matter of years. Now, with regard to the return home. Unfortunately, the space vehicle won't be able to land directly on Earth because it will be travelling too fast. In fact, it will be travelling at a velocity of 50,000 kilometers an hour. Thus, the space vehicle would have to hit Earth's atmosphere with millimeter accuracy, touching the surface of the atmosphere. This will obviously slow the space vehicle down. Then the space vehicle will fly off to the moon. On reaching the moon, the space vehicle will return on an elliptical orbit, having to enter Earth's atmosphere again. Once more, you would have to hit Earth's atmosphere with millimeter accuracy. Again, the space vehicle will hurtle off, but only halfway to the moon this time. Then it will return and have to repeat the process around 6 times. This will take around 10 days. Finally, the space vehicle will pass through Earth's atmosphere, landing in the ocean. Now, I'll close with this. Man is the consciousness of the universe. The consciousness of the universe has to be expanded beyond Earth for it to continue. The consciousness of the universe has to be taken to other frontiers for it to last. Thank you. Now, something else to consider. The problem is that once Mars has a thick atmosphere suitable for human existence, retaining that atmosphere produced may be a problem. The planet's gravitational field is not strong enough to retain an atmosphere. In time, it could be lost to outer space. Remember, gravity and atmosphere are intercombined in the sense that in order to retain an atmosphere, you need a strong gravitational field. So to summarize, because of Mars's weak gravitational field, retaining an atmosphere on Mars could be a problem. Over time, it could be lost to outer space. Hence, the key in retaining an atmosphere is we must keep the planet very, very warm. Now, I've already mentioned how cosmic radiation is a serious problem in terms of humans colonizing the planet. The health risks on Mars are vast because Mars lacks a magnetosphere. Thus, we also need to consider that the weak gravity on Mars will also pose health problems on humans. Changes will take place as a result within the human body, on the mind and so forth. Weakening of the bones and muscles, also risks of cardiovascular problems. However, over time, life adapts under certain conditions. Organism and environment change together. However, once we have domes on Mars, once safely inside, via a centrifugal force, you can simulate an Earth-like gravity. The Grav simulator will be fundamental for biological development and general well-being. Incidentally, it would be a good idea to have AI, robots working on the planet, whilst humans are safely housed within the shielded habitats, i.e. the domes, that can repel deadly cosmic radiation, highly energetic particles. Now for a philosophical question, human or Martian? Will humans born on Mars be classified human or Martian despite the biological and neurological essentials that make man? Over time, mankind will change, evolve. Biological, psychological and neurological changes are certain to take place. Hence, I guess that the biggest metaphysical question that will need to be answered is, will humans that are born on Mars be considered human? Will mankind lose its identity? Remember, we are our environment. Our environment shapes us. Organism and environment change together. Now, in terms of the journey to Mars, i.e. the arrival, the ship approaching Mars, the ship will go into orbit around the red planet. The ship will hit Mars's thin, high atmosphere at 40,000 kilometers per hour. The ship will move through the thin air at a speed and height calculated to put them into what is called transitional flow. Transitional flow is a state between free molecular flow and continuum flow. They will then hop out of the Martian atmosphere and the ship will slow down by approximately 19,000 kilometers an hour. After approximately half an Earth day, their new course will lead them to a periapsis 34,000 kilometers from the red planet. Remember, each elliptical orbit of the red planet will take around a day. Now, in terms of piloting the Mars descent vehicle down to the surface from the mother spacecraft, the main ship, the first part will be a nail-biting experience. In order for the Mars descent vehicle to fall properly, they will have to decelerate their orbital velocity. Once they hit the atmosphere at a speed of 28,000 kilometers an hour, they will encounter some turbulence, naturally, but thrusters will slow descent and control their lateral motion. As for the Mars Ascent Vehicle, this will be used for one reason alone: getting back to the main spaceship. The Mars Ascent Vehicle can in fact make its own fuel. This can be achieved with the help from the Martian atmosphere. The first step is to